So these whole the later part is for your reading. Is for information. It's a almost something is will be kept repeated, but uh, I mentioned that when you set up a research question, so this is a research question you can have, but what you need to do is that you have to set hypothesis to be tested. So check this part. Uh, the research question may be just a abstract way, but it should be tested anyhow if you collect the data. Okay. Yeah, key terms and variable definitions of them. Uh, that's okay. And some other designs. Yeah, the design itself is important, but um, just for your information, please read this part. And the samples, what we're gonna do is we're gonna the sample from population. So for example, you know, in Hawaii, let's say we have like a 1 million population, right? It is ideal to survey all of the Hawaii residents to make some research. 1 million surveys give out, yeah, no doubt about any statistic, just because that's a population value, okay? But realistically, it's impossible. How can we do the whole survey using all the Hawaii residents? Only could do through the census, but even census, every a lot of people doesn't just skip that, not answering those. In that sense, we need a sample, right? So to make a sample, it should be randomized. We cannot just focus on certain group or on a certain area. You know, that should be then the result must be biased, right? So we have to keep the randomness of sample. Uh, those things, so we have to set up like a scheme how should we to sample, and this should be describing those ideas. And for in terms of like a data, you know, you guys may heard about like the cleaning the data. Cleaning the data is not like a cleaning the house or cleaning the floor or anything. It's we have to clean the data. That means we have a lot of like a garbages in the data. So one of the example I can give you, I set the like a age as a one variable, right? Uh, then I give out to, okay, you guys should keep the format of age. Age should be number in years, right? Age should be in years. And when I receive the data, I check the summary. Then average of age it was like over 200 years. What? What was wrong with the data? Then I check the individual. Who made the mistake? And then I see that because they were confused with the inference data. Inference, usually they just check the weeks and days. They're not even achieving the year. So they said this all is messed up. Days and weeks and years, everything's collapsed. And then they make an average is, 200, over 200 years as an average. That happens. So I had to clean them, right? How how we work. So there are tons of other ways to protect or to prevent those type of errors, but we have to communicate well and set the uh, like a data protocol or dictionary to communicate with others. If you are like a principal investigator for any research, then you have to discuss with the data people, right? Oh, I have a plan to collect this data, but then for this data variable or data factor, I want to set this one as only for a certain format, right? For this one, this format. For this one is just only, I allow only just character. I only allow like a date. days, years. So you should know how you set your data, right? Not in your head. It just, you have to specify into some document, right? For this variable name, variable name itself, it could be very long or the small, but it should be decent, meaningful, like a variable name, right? Then for this variable, I want to set this one is a numeric format, right? I expect it should be range from this to this. Then when I read that your like a data description, or we call it just data dictionary, then I see that, oh, for this data set, the range is this one, and then the is expected to be like a number. Then I can check the data using the dictionaries, right? Otherwise, will take forever. Every weird data entries happened, then I have to call them. Oh, what is this? What is that? What is this? What is that? Will take forever. So, so just to communicate with the data entry people, well, that we need the data dictionary. Its purpose of that is to cleaning the data. Okay. Oh, I have to go back. All right. And but the other part is also description of how we do the like a data collection and the study, and this is for chapter 1. And I have like a chapter review, and yeah, I don't cover like a chapter review problems or questions, but some of question, if I had to, then I'll mention it, right? Right. For chapter 2, it's starting about like a data. So we're gonna do the organize and the display and the describe the data. So for this one, table 2.1 and table 2, yeah, continuation of table 2.1, you will see that what is this? This is mathematical symbols we frequently use in statistics. You don't have to worry too much about this one because I'm not asking you to calculate any statistics. But for the symbol, up to this one is fine, right? Plus, minus, multiply, divide. But summation, from the summation of xi is just summation of all entries for x variable, right? And the summation of xi squared is when I have like a xi things, then I need to make a squared, and the summation of from first to the end of the entries. But you should know the distinction between summation of xi squared and the summation of xi squared, right? Summation xi squared in general, I need to make just whole entries, make a squared, and then make a summation. But summation over xi and then make a squared, that means I summed up all the xi's, and then the quantities should be squared, right? So this is like a tricky. And less than or equal to, greater than or equal to, equal sign, and absolute value. And the PA is probability. All P things, P parentheses certain event, we utilize that as a probability, right? So you know the probability. So it's a number of cases out of like a total, like a number of possible cases. It's a probability. So like for example, like a probability A is, we utilize the symbol is when A is happening, right? Event A is happening. So we can't calculate the probability. And these three symbols for probabilities, A bar B is, I'll tell you later, but this is a probability of A event given conditioning B, right? So probability event A happening if B happens. It's like a more conditional probabilities. Then what is the conditional probability? I'll tell you later when this comes up. And the A intersection with the B is like an intersection area between A event and B event, and then we calculate the probability of it. It's just joint intersection of A and B. And A union B is just either A is happening or B is happening. It's more like a union, the event. So we have like a 3, 4 different types of like a mathematical function. And now we're gonna have like a statistical symbols. What we're gonna do is we're gonna I'm gonna describe this symbol, but when the specific things comes up, then I'll describe more specific, right? Alpha, we utilize alpha as a like a significant level. Then what is a significant level? I'll tell you later. And the P, don't confuse it with the like a P parenthesis certain event. This is just P itself. We called it just P value, right? So P value is one of the most important concept in the statistics. So using this P value, then we can justify that whether certain testing is a significant or not, right? So I'll tell you later. H0 as an index is a null hypothesis. Oh, HA is say that an alternative hypothesis. That means we have to set up like a 2 different hypotheses, alternative hypothesis and the null hypothesis. This hypothesis comes from your research question, okay? So I'll tell you later how you set up the hypothesis. And alpha error, beta error is a type 1, type 2 error. I'll tell you later about like these different types of error. And capital N is a population size, and the small n for the sample. So usually we utilize a capital, character as a population, but small character as like a sample, right? So when you write a paper, you will see that, oh, capital N was there, then means a population, right? But some people, some people are confused about that. Every time they use it, oh, capital, but it's like a standard rule of thumb. We utilize this symbol. For example, as a small, and F means a frequency, and the Pi or P95 is a little different than the probability. It's a percentile rank. So percentile rank is how much percentage you belong for a certain measure. So those are like a percentile rank. And the mu is, we call it just population average, and X bar is sample mean. So mean is the same as average. So sample mean and the population mean, but sometimes we just mix the symbol. And the sigma square, we called it just population variance, and the sigma itself is a standard deviation. And the S square is sample variance. S is just sample standard deviation, right? Then, oh, what is the variance? What is the standard deviation? Yeah, I'll tell you later. And the CI is a confidence interval. Then what we need is a confidence interval to make your the summary statistic is with a certain spreadness. Then we have to show the confidence interval. And the DF, we called it the degree of freedom. Degree of freedom is when we have like a data point, then how many data is required to present whole data, then we'll talk about like a degree of freedom. And this is a chi-square. This is a chi-square measure for certain types of testing. And the rho is a correlation efficient, and the R is a sample correlation efficient. So these whole things, eventually we're going to use for like the statistic calculation or symbol, but whenever this comes up, then I'll describe it, okay? Right, then we're going to talk about like what is a variable. Variable is just characteristic of the data, but it could be just any types of like certain characteristic for like a clinical characteristic or just demographic characteristic. It could be anything, right? But to describe a variable, then we have to set up like a measurement scale. So whether this variable into like a certain just numbers, or it has a certain categories, or it's just pure character, then we have to set it. So for measurement scale, there are like a nominal scales, ordinal scales, ratio scale, or interval scale, and the ratio scale, right? So if I go back, nominal scale is just it's like it's nothing to do with any order or numeric measure. It's just categories. For example, uh, when we set up a gender is a female or male, but we don't use a certain, you know, measurement quantitative measurement for female or male. We're just saying, okay, this is female or this is male, right? So we have two categories. Ethnicity, yeah, we have in Hawaii like a lots of these different types of ethnic groups, but we don't make a quantified, or we don't make it order like a 1, 2, 3, 4 or anything. We just set up like as a nominal this categories, right? But for certain variables need a like order, like a Likert scale. You know, when we do the survey, we do the Likert scale, right? But Likert scale itself, we can't tell it's just purely continuous measure, because it says like a 1 to 5, but it stopped at the 5, but there was no 0 at all. So 1 to 5, then for example of like here health status, 1 is excellent, 2 is good, 3 fair, and the 5 poor, and the 5 very poor. Then we know the order, but it's not like having certain meaningful into like a numerical way, you know. So we know the order, but it's hard to interpret that as like a certain numeric way. So for example, when I say oh, I have like a health status like a 1.5, but the Likert scale only allow like a 1 to 5, right? But 1.5 itself, I know what you're trying to do. I just show that maybe my condition is excellent, between excellent and good, but it's hard to measure in that way, you know. So when we set up like a Likert scale, then you gotta choose out of like a 1 to 5, right? So pain intensity as well. There's a 0 to 3. So those are like an order scale we can have. But we start have like an interval scale. Interval scale is now we're gonna have like a measured with a number. It's a meaningful numerical order with the meaningful intervals, but it doesn't have like a true 0, right? So for example, like a SAT scores, a GRE scores, MCAT, those type could be just interval. But when we start including the true 0, then we call it just ratio scale. So ratio scale that covers everything. So for example, like when we called it a continuous variable, this one is talking about like a ratio scale. Okay. So measurement scale is that. Yeah. So there's a descriptive statistic using those displays. In the research question, we could have this research question, then check how they just try to answer using the descriptive statistic, and then check how they answer using this describing the data. So for here is a frequency distribution table. It's just like a table. And for person number 1 to 17, and then they check this, the raw data, the body weight, right? Then what we're gonna do is we're gonna do the summary of at the end, and like a sum, this sum, then the sum of the square value. So we're gonna have this summary measure, okay? And then for frequency table for certain range or interval, then we can summarize it into this way, right? And creating the frequency distribution table is just, we have to set up like a certain status at certain column. And we just set up which measures we want to count. So for example, I want to just check the frequency. Then for a certain category that we have to count. So we have like a certain count, right? But not only for the count, what we can show is we show there like a certain percentages. So relative frequency is more like a percentage, right? And then that's the perfect summary statistics for certain outcome. Yeah. So yep. Okay, Sylvia. And for this summary also could be utilized by to show your data. You know, you're gonna show the data into some way, but you're not gonna tell for each individual data. You need a summary statistic. And there is others way over like frequencies and the relative frequency, the definition. Then I hope you to check this one. And yeah, frequency table is usually for counts data. And creating histogram, but before that, I want to show this one. So this is like a distribution of your data. So usually when the real world, we have like a normal shaped data. So we have like a lots of the counts on the average of value. So that's the normal curve. So this is all normal distribution. And then also we can have like a rectangular shapes and the bimodal shape, because we have like a the mode is like a more like a peaks. And then we may have like a U shape for the distribution. And we frequently will meet like a skew data. This is possibly skew data is right skewed. So like a long tail over right side for certain data. And also we can have like a negative skewed left skewed data. There's a long tail on the left side, right? So hoping to check this, how they just construct this histogram. And this frequency polygon also, and the stem and leaf plots. It's very easy for a stem and leaf plot to construct. And the data set from here. And the percentile rank, the cumulative frequencies of guides, so you can check this one. So they describe about like a percentile. The percentile is very easy, like a 50th percentile, 75th percentile. Yeah, certain percentile you could utilize, show that where your data is located. Yeah, so there's a different types of the chart and figure. Yeah, this is also. Yeah, so there are certain types of measures of a central tendency. We use a mode, median, and the mean. Yeah, those are central tendencies. So I describe on the slide. So please check those the module. And we have to utilize the measurement of the central tendency. So sometimes we don't need to check like every like a central tendency measures. So we just select those for certain circumstance. And yeah, hope you to check this one. Yeah, this is very important. When we have like a skew data, you know, the possibly skew data is maybe a lot of the data set is over here. So that means mean value is toward to the skewed part, but median itself is a central, like a center point. So we usually have a mode, median, the average in this order. So mode is leftmost because it's a highest peak. And the median is a center value. It's a slightly greater than the mode, but the average is highly affected by the large amount at the right side of like those skew data. So X bar which is a sample, the mean or average would be more toward to the right side, right? And the left skew, the data is totally opposite. So maybe if I give it a quiz, like, for positive skew, can you order like a mean, mode, a median, something like that, then yeah, you should be able to just check it, right? And the measures of dispersion. So we may have like a range. Check the definition of range. I described it. And the interquartile range, standard deviation and variance. Those things I already described on the module. And yeah, this is how we calculate, but you don't have to worry about the calculation. Yeah, this is also still calculating those. And the coefficient of variance, this is a definition of a coefficient variance. This is used when they're comparing the variance of two or more different variables. So when do we use a coefficient variance I just point over here. And yeah, so we also have like a different measures of a skewness or symmetry measure using, yeah. So it's using, where is, yeah, so your Pearson skewed coefficient or Fisher's measured skewness. So those things are used for the skewness. And measures of kurtosis. Kurtosis I also described in the slide. And for like this one is for more like a peakness. And we're gonna use a Fisher's measure of kurtosis. And then those things. And this is still constructing the frequency tables using the certain software, but you don't need, we're not going to use the SPSS at all. It's just describing that. Yeah, it's still constructing the frequency table. There's a chapter review for the questions over here. So far, do you guys have any questions? Anything?